Welcome back to the video, and today we're going to solve some properties of Laplace transformation. So first, we have this problem of e raised to 5t cos 4t sine 4t. So we can transform this using the trigo identities. So we have here your Laplace of your e raised to 5t. This will be turned into sine of 2 of your x, which is 4t, all over your 2, and we took out the 2 here, so this is 1/2 to e raised to 5t sine of 2 times 4, that will be 8t. From here, we can see we can use the first shifting method. Okay, so it will be like 1/2. So this will be your identities of your Laplace, which is your a, or your 8 all over your s squared plus 8 raised to 2. So your s will be equal to your s minus 5 based on your here. Then cancel out, then we replace the s here. This will be 4, so the answer here is 4 all over your, just insert here, so it's s minus 5 squared 8 raised to 2, that will be plus 64. So this is our next problem. So based on the cos squared of 3t, we can transform this into trigo identities, which is your cos squared x, which is equal to your 1 plus cos 2x all over 2. Okay, so we input it here, so the Laplace of your 4 times, this will be your 1 plus cos 2 times 3t all over 2. Okay, from there we can took out anything that has constant, so we have here 4 and 2, so this will cancel out, and what's left here is 2 Laplace of 1 plus cos, so 2 times 3, that will be 6t. And you can see here we're going to use a linearity property. So 2 Laplace of your 1 plus your 2 Laplace of your cos 60. So Laplace of a constant will be 1 over s, so this will be 2 over s. So your cos will be equal to your s all over your s squared plus 6 raised to 2, so this will be 36. So we simplify further, so we got 2 over s plus this will be 2s all over your s squared plus 36. This is your final answer. Okay, so this is our next problem. As you can see here that we have e raised to 2 sine of 2t over t. So first, actually we're gonna do is we're gonna use the first shifting property. So in this case, this will be equal to, so your e raised to 2 sine of 2t, this will become your sine 2t all over t with s, which is going to s minus 2. Keep this in mind. So here we can use the integral of Laplace transformation. So this will be the 0 to infinity, positive infinity. This will become your, so it will be 2 all over your s squared plus 2 raised to 2, so this will be 4. And don't forget we have s will be equal to s minus 2. So the integral of this, since it's the reciprocal, so this will become your arctan of your, so s all over 2. with respects to 0 to positive infinity plus, let's say, plus your s will be equal to s minus 2. So let's put the s here, and we can also put the infinity and the 0. So what we have is arc tan of s. So this will be infinity minus 2 over 2 minus your arc tan of your s minus 2 all over 2. Okay, so we know here this will become pi over 2. So the final answer is pi over 2 minus arc tan of your s minus 2 over 2. Okay, sorry for that noise because it was raining. So here we have our next problem. So this is your e raised to t plus 2 sine t plus 1. So you notice that this is very similar to your second shifting property. So what to do is let's try to transform this. So let's have here e raised to t plus 1 sine of t plus 1. So this is so similar. So let's make it more easier. So you have e1 times your t plus 1 sine of t plus 1. So this is already a constant, so we took this out, and now we have here your second shifting. Okay, so your a here is equal to -1. So your f of your t plus 1 is equal to your e t plus 1 sine of t plus 1. So we took out the plus 1 here, so your f of t is just equal to your et sine of your t. And from this we can use our first shifting. So your sine here will be your 1 over s squared plus 1 squared all over your s, or your s is equal to your s minus 1. So your answer here is 1 over s minus 1 squared plus 1. Okay, this is our last problem. So as you can see here that we can transform this sine raised to 2t into sine 2t, or 2x is equal to 1 minus cos 2t all over 2. So the Laplace transform of your t times your 1 minus cos 2t all over your 2. Okay, then we simplify this further. We can let the constant be inside of the Laplace. So this will become t over 2 times your 1 minus your t over 2 times your cos 2t. Okay, so you can see here we're going to use the linearity property. So your L of your constant, or you just say 1 over 2 times your t minus your 1 over 2 Laplace of your t cos 2t. Okay, so here we all know that the Laplace of your t is just 1 over s squared. So this will become 1 over 2s squared. Here we can use the derivative of the Laplace transformation. Okay, so this will become 1/2 to negative d all over dt of your cos. So this will be your s all over your s plus s squared plus 4. So this derivative of this, it will become 1 over 2s squared minus 1/2. This one will become your negative 2s squared plus 4 all over your s squared plus 4. And this will, okay, from here, so this will be 1 over 2s squared minus 1/2 minus your negative or your 2s squared plus 4 all over your s squared plus 4. Okay, from here we can cancel out the negatives. Oh, forgot this will be raised to 2. Okay, so the final answer here is 1 over 2s squared minus your 1 half of your 2s squared plus 4 all over your s squared plus 4 raised to 2. Today I learned about the properties of Laplace transformation. I learned that it's very easier now, because before we tried to use integration, then we use tabular. Now we're gonna use the properties, but the properties are really easy, and I hope that the next topic, I think it will be inverse, which will be much easier if we fully understand the Laplace transformation. And thank you so much, and see you in the next video.